Hello, Pamela. Uh-oh.
No, I
Audio
just hadn't
shenanigans.
I hadn't hit the mute unmute button yet. You caught me by surprise. I was still trying to figure out how to launch everything.
Press the big red button.
I understand that, but I was trying to
Launch button.
share all the things, and I'm still sharing all the things.
Isn't it mind-bending how much of our world we live out on the other things than our own websites?
Yes. Yes. Well, it's because you and I do many different
That's
things.
true. There are many hats. Yeah, yeah. And every time a new service gets added, I get really excited, and I also get tired. Like, oh,
Yes.
Pinterest, this is so cool. We can post space pictures here, and so tired. So,
Yeah.
right, so for all of you watching this, we apologize that this is a very strange time on a very strange day. This was not a plan, but Pamela
I had
got
the flu.
the dreaded lurgy, and she was literally not able to talk, and really wanted to remain horizontal for a few days. And so as of Monday, she was able to talk, and then we just need to catch up an episode, and then I'm going to be gone next week. So and so we're going to record the episode that would normally get done on Monday, and so now we'll all be caught up. So we're going to do one episode right now, quickly, and then we're going to do a second episode. We're going to shut the whole machine down, and we'll start all back up again, and we'll do our second episode, and then we'll stick around for some questions. I mean, it's going to be kind of long, I know, but all right. That'd be cool. Okay, cool. So if anyone has never seen this, if this is the first time you've ever done this, this is an episode of Astronomy Cast. We're going to record episode 333, When Worlds Collide.
Yes.
That is going to go... You lost your lower third.
You're right,
Um,
I did.
who are you? Who
Where
is
did
this
it
person?
go?
I don't know.
The
So we'll record the
technology.
episode, and then when that's finished, we will shut the whole machine down very quickly. So, but you can, if we make some horrible mistakes, or if you have some quick questions, you can throw them in to the Q&A app, which I have enabled. But, well, I'll admit we won't answer them this time. So, but save them for next time, and just remember that. So.
Save them for half an hour. We'll be back in it.
Yeah, we'll be back again. So we're like
Yeah.
literally we will shut this down. We will drink beverages, reorganize all of the administration side, and we'll bring the second one up, and then we'll go. So, um, it's February. What did I say? January? No. What?
I pay
Thomas
no
has just
attention to these
Thomas just
months
said
of the
something.
year things.
Yeah, I know. So, yeah. Thomas just said, hey, Mr. Fraser, it is February. I don't know what that means. You have to explain in more detail. Because you're freaking me out. That's why the problem is. Okay, cool. So you ready to go?
Sure.
Can you tell that I just did a whole episode of the Weekly Space Hangout and I'm completely jazzed up? 4 cups of coffee also.
Holy
Yeah, this is good.
expletive,
I
Batman.
know, I know. Me jazzed up is a terrifying sight to behold.
Yeah, and I've been fighting caffeine headache all day, so we're coming at this from the opposite sides.
You're right. Your dose is starting to wear off.
I have the coffee.
All right, so say when I can press record.
I am pressing record. It's recording. It's using the right things in mono. It's recording. Hi, Preston.
Hi, Preston. Okay, here we go. Astronomy Cast, episode 333, When Worlds Collide. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
I'm doing great. Cold though.
Oh,
Yeah, it was like minus
okay.
12.
Define cold.
Minus 12 Celsius. My pipes froze. My toilets don't work. It's it's cold for West Coast of Canada.
Okay, we're running about the same
Yeah.
temperature here, so
Now before we get on to the show today, there's a little bit of promotion going on for Astronomy, 365 Days of Astronomy. Did you want to
yes.
mention that?
Yes. So our 365 Days of Astronomy podcast, a winner of the Parsec
Parsec
Award.
winner.
Yes, unlike Astronomy
Unlike
Cast.
Astronomy Cast, yeah.
It's It's a community paid for podcast that relies on donations from people like you, but we just haven't been getting the donations we need this year. It's like people forgot that donating made it go. So our number of listeners is going up and up and up, and our donations are going down and down and down. And I love my staff. I'd like to pay Aviva and Richard continually, forever and always, so that we can keep sending you science fiction stories, science stories, interviews, all of the wonderful, diverse content that we have to offer. So if you can help support the show, that would be absolutely amazing. There's a donate button on the right-hand side of 365daysofastronomy.org, which will redirect you to their CosmoQuest page. And help. And another way you can support that show and this show actually is to buy our apps. We have podcast apps that are in the iTunes and Android stores. Just look up 365 Days of Astronomy or Astronomy Cast. We also have CosmoQuest apps only for Android there. But you can support all of us by buying our apps and getting something you can learn from. Fraser has his Universe Today Phases of the Moon app. And sometimes your purchase of educational material helps us educate the world.
Awesome. And also contribute shows. We're always
Yes.
looking for more people to
Yes.
participate. And I did a bit of a rant in the Weekly Space Hangout this week, which is that, we have really organized this whole community to be as inclusive as we possibly can. There are so many ways that you can get involved and connect with us and connect with other space fans and create content and get that content out to a wide audience. We want to help you, so just reach out and let us know.
And to use the NPR line, National Public Radio here in the U.S., don't just rely on somebody else to donate, because that seems to be what's happening is people are like, I donated this year, I donated last year, this year is somebody else's turn. Well, the problem is when everyone assumes this year is somebody else's turn, no one ends up donating this year. So please consider helping if you can.
All right, let's get rolling. So just take a look at the surface of the moon, and you can see it experienced a savage beating in the past. Turns out the whole solar system is a cosmic shooting gallery with stuff crashing into other stuff. It sure sounds violent, but then we wouldn't be here without it. So this is this idea that really the entire history, the evolution of the planet Earth comes from stuff smashing into each other.
Yes.
Like it's very counterintuitive that really we wouldn't be here if there wasn't apocalypse after apocalypse.
Well, hey, it's what erased the dinosaurs and allowed us to evolve into being the master beings at the top of the food chain.
Move over, dinosaurs.
We don't need you, T-Rex. Go away with your tiny little arms.
So then let's kind of go back to the beginning, and we'll start with this sort of the solar nebula concept, and then sort of push that a little forward until we get to the point that appreciable objects are smashing into other objects. How did this happen?
Well, the how has to do mostly with, you take two things and set them loose in a solar system, and there's a fairly good probability that given the fullness of time, they will hit each other. And it just happens that in our own solar system, for instance, the orbit that the Earth started out on and the orbit that another object started out on, an object roughly the size of Mars, intersected about 4 to 4.5 billion years ago. And when those two orbits happened to intersect at the same place at the same time, we formed our moon. We lost some of our crustal materials. We gained a bunch of heavier materials. And we ended up with a uniquely composed Earth and moon.
But I mean, these kinds of collisions have been happening probably before that. I mean, that was one gigantic collision, but in any case, the very existence of the planet itself was caused by collision after collision.
Yeah, so that's the collisional accretion model. So there's collisions that occur both elastically, inelastically, and what that means is you have collisions where two things essentially stick together. So if you think about it, every time we have a small rock come along and get sucked gravitationally toward the Earth and colliding with our planet gets bigger by that amount of stuff. So that's collisional accretion. Well, in the early solar system, we were basically a giant dust bucket of a solar system, and larger particles of dust gravitationally pulled in and happened to collide with other things, and they stuck together via chemistry, via the electrostatic force, and eventually via gravity.
Well, sorry, just to interrupt you, that electrostatic force, that's one of the amazing parts for me, is to get that whole process started. Before you had gravity, you
had chemistry.
Chemistry and electricity, right? Negative and positively charged stuff sticking together, right?
It's chemistry was definitely one of the larger ways that once things got going, things stuck together. But yeah, it's all part of the total story of things are held together, not just with gravity, but also through molecular bonds, through ionic bonds, so ionic, covalent. All of these things come into play in creating worlds. And what has the bigger part depends on, are you looking at a tiny potato or are you looking at a giant sphere? It's those spheres that are definitely gravitationally dominated. In fact, it's gravity that is causing everything to crush down to its equal potential surface and being nice and spherical.
Right, and so you've got this situation, you've got these tiny little pieces of dust, they're pulling together, they're collecting into larger and larger gravel-type things. Those are collecting together into rocks, piles of gravel, and eventually it's sort of clumping the whole solar system together into all these blobs of matter.
So yes, we have this constant increasing of blobs. And if you've ever watched snow on a day where you have the nice drifting snowflakes, that the snowflakes will collide together until you get something that isn't so much a snowflake as a giant blob of snowy substance falling from the sky. That's a collisional accretion process. It's just a less violent one than we think of when we think of what happened in the early solar system.
So, I can imagine these sort of larger, they're asteroid-sized, and they're becoming moon-sized, and they're smashing into each other, right? And at a certain point, like, when did we kind of get the planets, pre-moon creation, when did we sort of get the planets that we're seeing today?
We started to get them about 5 billion years ago. And one thing to remember is when you do that crunching, crashy thing in your head, you're forgetting that everything started out molten. So initially you actually had two molten blobs of mud, essentially, except hot instead of wet. Well, it was wet too in some cases. So you have liquidy things colliding into one another, so it's more like sploosh.
That's why I said blobs.
Yes, right. but then you made crashy noises.
Oh, yeah, all right.
Yeah, it's
I'll
more
work on my sound effects.
Yeah, I don't know how to make a good splashy noise either. But so you had these molten splashy objects merging together into larger and larger bodies, starting to cool off. Planets really evolved quickly. Some models show that it only took about 300,000 years to start getting things like Jupiter. So it was a very rapid process. But then, so we had about 4 to 4.5 billion years ago, we had an object the size of Mars collide with the original Earth, and in that process, their heavy cores merged.
Okay, now hold on a second. So you're glossing over a very fascinating piece of information. Like, at one point, Mars-sized thing crashed into the Earth. You got a moon. No. Back it up. So what was going on? Like, there was the Earth, and there was like a Mars-sized or two Mars-sized objects. What was?
Well, there was Mars,
like?
Clearly. So this is the thing. In the process of running our solar system backwards, there's no definitive answer. We know that early in the solar system's history, things were in a different place. At one point, we had Jupiter and Saturn in a resonance such that for every one time Saturn went around, Jupiter went around twice. And when that happened, all hell broke loose. You had gravitational resonances that were flinging things in and out all around. Heavy bombardments ended up occurring. So you had the outer solar system evolving through these different resonances. Uranus and Neptune probably started in very different locations than where they are now. We have all of the weirdnesses in the outer solar system from well, Uranus is spinning on its side,
Yeah.
basically,
Venus is spinning
upside down.
backwards. Yeah, upside down. Right. And so I envision it like cars speeding on the highway, right? And you got these like lanes and lanes and lanes of traffic. And in the early solar system, it was 13 lanes, and everybody was changing lanes and not checking their blind spots. Right?
Well, and doing it during a snowstorm so that
Right.
when they collided, they just kind of spun all over the place. It's been snowing a lot. That's the metaphor I'm going to go with today.
Yeah, yeah. So just mayhem. So would it have been like a Mars-sized object had gotten pushed into Earth's orbit, or were they sort of interacting with resonance and then they just kind of crunched
We
into
don't
each other?
know. We don't know. It
Okay.
was the early, yeah, it's how that sort of thing happened. There's multiple models, and we just can't get there from here. There's so many things that have happened in the interim. Um, Roughly 3 to 3.5 billion years ago is when we were looking at massive bombardment all through the.
Not
Sorry,
quite better yet.
no, not quite better. It was 3 to 3.5 billion years ago that we were looking at all sorts of bombardments going through the inner solar system. 3.8 billion years ago, and then of course we have to worry about things that erased the history. So we still had volcanism in the past on Mars. We still had, well, it wasn't so much volcanism on the moon the way we normally think of volcanoes, but there were certainly lava flows in the moon getting formed 4 billion years ago. It took time to cool off and settle into its current shape. So it's really hard to decipher what happened in our universe that far back.
Right. So at some point, Earth was driving along in its lane, perfectly happy, and someone in a Mars car smashed into it. What happened?
So I think
And
they're
not
the
actual
best.
Mars,
No, it was
a
a
Mars-sized,
Mars-sized
another Mars.
different object, and I think the way to think of it is there was a missing yield sign, so no one yielded the way.
It just merged.
They
Yeah.
just merged.
Yeah. Okay.
Yeah, with no getting into the left-hand lane. So yeah, we had these two objects going along, minding their own businesses, and then trying to occupy the exact same space. And when you have massive collisions like this take place, you have all of the kinetic energy of the collision getting released as heat. That remelted, it caused a giant splash of the lightweight material, a merger of the cores, and essentially this is where the moon came from. For a while, the Earth probably had a ring of material. The ring of material coalesced into the moon. Some of it fell back down to Earth. Um, it was a violent event, but it wasn't unique. That's the thing to stress.
Yeah. Yeah. Well, that's the thing, right? Is like this is just one that we know of because we've got a piece of evidence. A moon.
And so far we've restricted our conversation to this solar system, but we now know our solar system is one of countless solar systems that are out there. And there's actually this really neat discovery all the way back in 2008 of a solar system that was about the age of our solar system. So it wasn't young. It had been hanging out for a long time, fairly well evolved. And it looks like two planets, one the size of Earth, one the size of Venus, collided. And in the process of colliding, just created a giant dust belt. There was nothing left.
Right. It's like Star Wars, right? Where they go
No
looking
Death
for
Star.
Alderaan. Yeah, without a Death Star, But why have a Death Star when you can just crash a Venus into an Earth? So we see the results of this impact here with the Earth and with the Moon, and the distance of the Moon and what the Moon is formed out of. One piece of research, I don't know if you'd heard that maybe the idea was that one of the explanations for the weirdness on the far side of the Moon is that there was a second Moon that sort of slowly impacted onto the backside of the Moon ring.
Right. So that particular model has a giant splash occurring, essentially a ring forming, then a large body and a smaller body, both forming, and over time they caught up with one another, and the smaller body whacked into the backside of the larger body, and that became the near side and far side of the Moon, and it explains why the high density core of the Moon isn't actually in the center of the three-dimensional Moon.
So more weird evidence is Venus. As we mentioned,
Yes.
it's upside down.
And Venus is actually one that is more frustrating to understand because there's two different ways of looking at it. You can either look at it as the result of an impact flipping it over potentially, but there's nothing looking at its surface to prove that, but the thing has been resurfaced recently by volcanism, we believe. And then the other way you can look at it is some sort of a resonance interaction over time, potentially even with the Earth, could have torqued it and torqued it and torqued it until it flipped over. So you can do theoretical models either of collisions or of this gentle nudging over time, and in both cases managed to flip it on its head.
Right, and you could end up with a situation where it too could have briefly had, gotten smashed by something, had a cloud of material, had a moon, but if the moon was below the Roche limit,
It would have gone back
it would
down,
have
which
gone
is
back.
actually what we're seeing happen with Mars. Mars is eventually going to get impacted by its lowest moon.
So more evidence. Let's talk about Mars. Captured asteroids?
Captured asteroids.
Yeah? Okay. Not similar formation as to what happened with the Earth.
No, and in fact, this is something that we see repeated over and over throughout the solar system. Is many of the worlds have captured asteroids orbiting around them. I actually am kind of amazed that we don't have a captured asteroid floating around the planet Earth. So yeah, our solar system is filled with rocks. Gravity reaches out forever, and when things pass one another with the correct difference in velocities, instead of an asteroid flying by, it ends up getting captured into an orbit. We also see this happening with Kuiper Belt objects, where Neptune's Titan appears to be a captured Kuiper Belt object. Triton, not Titan.
Triton, right.
Neptune's Triton appears to be a captured Kuiper Belt object. Our solar system is filled with rocks and ice that got captured from other places.
Okay, well, explain Uranus.
That one, it was either something where it got seriously torqued during this. There was probably a period of time in the past where we had all four of the giant planets, the ice giants and the gas giants, in basically a tumbling blob of inter-orbiting objects. And it could have, during those interactions, gotten flipped over through some sort of a torquing mechanism, or it could have happened via collision again.
So there would have been like another Neptune or something that smashed into it?
It wouldn't have necessarily had to have been another Neptune. It could have been a smaller, more dense object. Lots of different things. It's all a matter of the rate at which two things collide together and their masses. So you can either have slow and big or fast and small.
Now, there were some periods in the history of the solar system where the mayhem was cranked up to another level, and the sort of big famous one of this is the late heavy bombardment. So what was going on there?
Its name really says it all. It was a period where we had all sorts of rocks from throughout the solar system, so minor planets, small bodies, getting flung in all directions. And as a result of this, and this was related to Jupiter and Saturn being in resonance with one another, this is that Jupiter going around twice for Saturn going around once period. We believe that may have been one of the driving actions for it. But we're still trying to figure out all of those things.
Well, what would it have been like to be living on the Earth during that period?
very
Apart from suicidal, like apart from it
well.
being a death sentence, what would it have been like?
Well, so first of all, the Earth hadn't fully cooled yet, so you're dealing with a very different planet. Our
Fine, I'm on
oceans,
my lava boat, looking up.
our planet was fairly free of volatiles at that point, so not a lot of water, not a lot of carbon dioxide, all those sorts of things, and so they were starting to get delivered probably via comets. So the heavy bombardment was a good thing from that perspective. Um, but instead of getting a giant thing hitting us every couple million years, it was happening probably every few thousand years.
And you can see that in the story in the surface of the moon. All of these craters that were formed within a few 100 million years of each other.
And and it out to about a billion year period. And this is when we saw some of the biggest craters on the moon forming. The giant basins that you look at, it was a time when there was also just more debris around. So at the end of the late heavy bombardment, there just wasn't as much stuff to do the colliding.
So we're now, things have calmed down, things have settled down with our solar system, not as much stuff flying around, but there are still some collisions happening all the time and even in our future.
And this is where the topic of our next episode comes from, the Chelyabinsk impact in Russia. The solar system's still filled with rocks of varying sizes from a few centimeters to kilometers to tens and hundreds of kilometers across that are on orbits that aren't entirely stable, which means they will evolve over time, and on Earth-crossing orbits. These are the Apollo class of asteroids, things that have a greatest distance from the sun that is quite often out in the asteroid belt, but a distance closest to the sun that's closer than the Earth is to the sun. That means they cross our orbit twice a year. If we happen to be in the same place at the same time, which is what happened with the Chelyabinsk asteroid, which became a meteor, which hit, then you end up with collisions.
And what kind of, like, how common are these collisions going to be? I mean, how rare, and we'll get onto the Chelyabinsk in the next episode, but like, what can we expect over the next few thousand years?
Well, this is something that we're still trying to figure out. This is where space projects like the Large Synoptic Survey Telescope that's getting built down in Chile are so important, because we don't actually have a complete census of all the asteroids. So I can tell you, as near as we know, things at the Tunguska side are a every few hundred-year event. Things like extinction level events are probably a every couple 100 million-year event. But we don't know that. Now, one of the nice things that we do know is recent models to look at the dynamics of the inner and the outer solar system find that for at least the next 5 billion years, the orbits of all of the planets, when you run numerical models taking into account all the asteroids we do know and different projections for what we don't know, when you run all those numerical models, there is essentially zero probability of worlds colliding for 5 billion years. And you know, in 5 billion years, the sun blows up, we all get fricasseed anyways. It's not going to matter what happens in 5 billion years. So the planets on their orbits today are nice and stable. And in our solar system, we're not going to be witnessing any massive collisions anytime soon.
Well, you already jumped to my next question, which is to run things far, far forward. So in 5 billion years, we're not going to see the orbits move around at all. But when the sun does blow it up as a red giant and the solar wind kind of kicks up, we're going to see some shifting a bit?
We'll see everything migrating. So what happens is, as the sun loses mass, objects' orbits, the thing that they're orbiting is no longer the same size, so their orbits end up expanding out. So the Earth, Mercury just gets eaten. Earth is going to migrate out, Mars is going to migrate out, everything's going to migrate. It's going to be an interesting time that we shan't witness. But as
Speak for
far as we
yourself. I'll be on
know,
my third robot body by then.
as far as we know, um, the Earth will stay outside of this expanding red giant star.
And then, though, it's going to turn into a white dwarf.
Right, and
Will the stars, so will the planets remain in their same orbits, or will they
right
shift inward again?
no, so their orbit doesn't depend on the diameter of the thing they're orbiting. It depends on the mass of the thing that's being orbited. So you can take the sun and squish it down until it's a few centimeters across and has the density of a black hole and acts like a black hole. And our orbit won't change at all. You can expand it out, and the only reason the orbits change is because during the expansion, it loses mass. Once it's done losing mass and collapses back down to a white dwarf star, well, it still has the same mass after the collapse. Therefore, the orbits don't change.
Right, unless you were really close and somehow get caught in the gravitational frame dragging or something like that, right?
Right. Now, to be clear, the entire envelope of the star gets lost as the sucker becomes a white dwarf. So what's left behind is the core of the star. But it's the losing of the mass, not the diameter of the star, that causes orbits to change.
And then, I mean, if you then ran those orbits for billions, trillions, quadrillions of years into the future, as the
You
universe
can't.
expands.
Well,
Would
the
the,
universe's expansion has nothing to do with the
no, I know,
planetary
but I'm just saying,
orbits.
like, the universe is going to be around for quadrillions of years after the sun dies. So will they eventually crunch into each other and form one big planet?
We
Orbiting the
don't
white
know. I
dwarf?
mean, that's the thing is numerical models are unstable at that point because we don't know all the different factors that will occur. We don't know are other stars going to pass too close to our solar system. We don't know all of these different things. And it's going to depend on what hits what, how much mass the planets absorb via the mass loss of the sun, all those different effects. Solar heating will have an effect on the orbits of smaller objects. There's lots and lots of variables, and so the models aren't stable more than a couple billion years. They're really not stable for more than a few thousand years for the small objects, but for the bigger stuff, you can go a few billion years.
Right, but not the few quadrillion that I'm trying to
No,
go out to.
can't go there.
All right. Cool. All right. Well, thank you very much, Pamela.
My pleasure.
Stop.
Pausing the recording.
Save.
We got grouched at by someone on Twitter because we didn't get to the point fast enough.
We never do. What's the point? What point did they want?
I don't know, but they said that they stopped watching us because we didn't get to the point fast enough.
No. It makes me so sad. So episode 333, halfway to the number of the beast.
It's an Asmosian. It's someone from Penny for NASA. We annoyed someone at Penny
Oh,
for
really?
NASA.
Okay.
Yes.
I'm going to send them a refund.
Okay.
Okay. So we should wrap this up. And then we're going to pause, have a beverage, and
Yes.
get back and roll again in 15 minutes. We'll start at 3:45 Pacific Standard Time. Does that work for you? Does that give you enough time to?
My coffee is already right here.
Okay.
So
right.
I'm good to go now.
Okay. Well, we should. Okay. Well, then I will shut this down. I got to do a little bit of administration, and I want to make sure this upload is going, and we'll just start it back up again.
That sounds good.
Awesome. So for all the people who answered, there's so many good questions here.
Screen capture it. Screen capture it. Curly thing. What is it?
I don't know if I can from the question thing. I don't think I can. Let me
You
see.
can screen capture from anything.
Oh, okay. Well, I want to copy the text.
Okay.
Um.
I'm going to be so glad when I have my voice fully back.
Okay, I think I've got it. Okay. All right. We will.
Okay.
I will shut this down, and I will invite you to your next hangout, and we will start the whole machine up again. So thanks everyone for tagging along on this strange adventure. We'll see you guys. We'll see you guys shortly.
Okay.
Hello, Pamela. Uh-oh.
No, I
Audio
just hadn't
shenanigans.
I hadn't hit the mute unmute button yet. You caught me by surprise. I was still trying to figure out how to launch everything.
Press the big red button.
I understand that, but I was trying to share all the things, and I'm still sharing all the things.
Isn't it mind-bending how much of our world we live out on the other things than our own websites?
Yes. Yes. Well, it's because you and I do many different
That's
things.
true. There are many hats. Yeah, yeah. And every time a new service gets added, I get really excited, and I also get tired. Like, oh,
Yes.
Pinterest. No, but all right, that'd be cool. Okay, cool. So if anyone has never seen this, if this is the first time you've ever done this, this is an episode of Astronomy Cast. We're going to record episode 333, When Worlds Collide.
Yes.
That is going to go. You lost your lower third.
You're right,
Um,
I did.
who are you? Who
Where
is
did
this
it
person?
go?
I don't know.
The
So we'll record the
technology.
episode, and then when that's finished, we will shut the whole machine down very quickly. So, but you can, if we make some horrible mistakes, or if you have some quick questions, you can throw them in to the Q&A app, which I have enabled. But, well, I'll admit we won't answer them this time. So, but save them for next time, and just remember that. So.
Save them for half an hour. We'll be back in it.
Yeah, we'll be back again. So we're like
Yeah.
literally we will shut this down. We will drink beverages, reorganize all of the administration side, and we'll bring the second one up, and then we'll go. So, um, it's February. What did I say? January? No. What?
I pay
Thomas
no
is just
attention to these
Thomas just
months
said
of the
something.
year things.
Yeah, I know. So, yeah. Thomas just said, hey, Mr. Fraser, it is February. I don't know what that means. You have to explain in more detail. Because you're freaking me out. That's why the problem is. Okay, cool. So you ready to go?
Sure.
Can you tell that I just did a whole episode of the Weekly Space Hangout and I'm completely jazzed up? 4 cups of coffee also?
Holy
Yeah, this is good.
expletive,
I
Batman.
know. Me jazzed up is a terrifying sight to behold.
Yeah, and I've been fighting caffeine headache all day, so we're coming at this from the opposite.
This is so cool. We can post space pictures here, and so tired.
Yeah.
Right, so for all of you watching this, we apologize that this is a very strange time on a very strange day. This was not a plan, but Pamela
I
got
had the flu.
the dreaded lurgy, and she was literally not able to talk, and really wanted to remain horizontal for a few days. So as of Monday, she was able to talk, and then we just need to catch up an episode, and then I'm going to be gone next week. So so we're going to record the episode that would normally get done on Monday, and so now we'll all be caught up. So we're going to do one episode right now, quickly, and then we're going to do a second episode. We're going to shut the whole machine down, and we'll start it all back up again, and we'll do our second episode, and then we'll stick around for some questions. It's going to be kind of long.
Besides,
You're right. Your dose is starting to wear off.
I have the coffee.
All right, so say when I can press record.
I am pressing record. It's recording. It's using the right things in mono. It's recording. Hi, Preston.
Hi, Preston. Okay, here we go. Astronomy Cast, episode 333, When Worlds Collide. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Kane. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing?
I'm doing great. Cold, though.